the convex lens under this wave and optics topics. I'm Dr. D.P. Nade from Bharati Vidyapit, Dr. Patagarav Kadamba Vidyalaya, Sangli. Let us consider the thin convex lens. So thin convex lens have the XY is the center part of this convex lens, and consider that this is the principal axis of the lens, and here we have the object. So object is the I have given the name as a object O, and it is at the distance from the center of the lens at the U. Suppose that this object is the emitting the light towards the lens, so then it will be incident on the lens. Lens have the two curvature paths, so this is the first curvature path and this one is the second curvature path, so that whenever light is travel from the air medium to the denser medium, so suppose that this is the air and that is the rare medium, we can say that this is the denser medium. So whenever the light is travel through this medium, so light can be bent towards this and it will be again emerge out at the point I. But due to this two curvature path, it will be for at the I1. So this is the point where we can see the image of this object. So object O is here and image will be formed at this point, and it is totally depends upon the distance. So we can consider that the distance from this center of the lens to the image is V. So this is the distance. Now we can consider that this curvature path of the or curvature of the lens. So this C1 is the center of curvature for this part of the lens. Okay, we'll show you. So this part of the lens. So this part of the lens is the curvature is here, and by that we can consider that R1 is the radius of curvature of this part of the lens. Similarly, we can consider the radius of curvature for the this part, that is the next part, this one is the center of curvature is this one, that is the R1. We can find out the relation between R1, R2 and V and mu. So that relation is simply given by this formula 1 by V minus 1 by U, that is equal to mu minus 1. So mu is representing the refractive index of the medium into bracket 1 by R1 minus 1 by R2. This formula is called as a Gauss formula, and if we consider that, so this object is at an infinite distance, suppose that infinite distance, so for that I can consider here one example. Suppose the sun is here and it can be radiate the radiation in all possible direction, and that radiations reaches at the surface of the earth from here. So in that case we can say that the object is at an infinite distance, that is the u is equal to at the infinity. So if in that case, if the u is equal to infinity, so I can put it here the infinity, then 1 by u, nothing but 1 by infinity, and that is equal to 0. So my equation becomes 1 by f is equal to mu minus 1 into bracket 1 by r1 minus 1 by r2. So here I consider that V is equal to F, and at the condition if U is equal to infinity and V is equal to F, This is called as a lens maker formula. This is a very important formula. It is called as lens maker's formula. By this two equations, I have the one equation. This is the equation number 1 and equation number 2. From these two equations, we can say that the 1 by V minus 1 by U is equal to 1 by F, and this is called as a Gauss formula for the lens. So today we will stop here, and tomorrow we will discuss the next point of the same unit. Thank you.